Hello, and welcome back to Sleep Science Fact. Tonight, let your thoughts slow down, your breathing soften, and your attention gently drift outward, far beyond Earth, beyond the Sun, and into the vast, quiet story of our home galaxy. The Milky Way is not a frozen picture in the sky. It is not a finished structure, calmly resting in space. Instead, it is something much closer to a living system, slow, ancient, always changing, even when that change is almost impossible to notice. As we continue from the previous section, where the Milky Way was introduced as a dynamic and evolving galaxy, we now allow ourselves to linger within that idea, not rushing, not seeking an ending, only observing how growth unfolds when time itself stretches across billions of years. The Milky Way began its story more than 13 billion years ago, not long after the universe itself emerged from the hot, dense state we call the Big Bang. In those earliest moments, there were no stars, no planets, no galaxies, only a nearly uniform sea of hydrogen and helium, drifting in the expanding darkness. Very slowly, gravity began to do what it always does. It gathered, it pulled, it whispered matter together. Tiny irregularities in that early universe became seeds. Regions just slightly denser than their surroundings started to attract more material. Gas flowed inward. Dark matter, invisible yet massive, formed enormous halos that acted like cosmic scaffolding. Within these halos, the first proto-galaxies were born. The Milky Way did not appear all at once. It grew piece by piece, fragment by fragment, a quiet accumulation rather than a single dramatic event. In its youth, our galaxy was smaller, rougher, and far more chaotic than it is today. Star formation was intense. Massive stars lived fast and died young, exploding as supernovae and enriching their surroundings with heavier elements. Each generation of stars changed the chemical makeup of the galaxy, making future worlds more complex, more structured, and eventually more capable of hosting life. Even now, the Milky Way continues to grow, far beyond the familiar glow of its spiral arms. The galaxy is constantly drawing in fresh material from intergalactic space. Streams of cold hydrogen gas, almost invisible, flow along filaments of the cosmic web and slowly rain down onto the galactic disk. This gas becomes the raw material for future stars that have not yet ignited. When you look up at the night sky, it may feel as though the Milky Way has always looked this way. But that feeling is an illusion created by our short lives. In reality, the galaxy you see tonight is only a brief snapshot in a much longer story. Over millions of years, the shape of the Milky Way subtly shifts. Its spiral arms are not solid structures. They are patterns, like traffic jams of stars and gas, moving through the disk. Stars drift in and out of these arms, forming, aging, and eventually fading away. Over hundreds of millions of years, the entire galaxy slowly rotates. Our Sun, carrying Earth along with it, orbits the galactic center at an immense speed. Yet the journey is so vast that one complete galactic year takes about 225 million Earth years. Since the Sun was born, it has completed only a small number of these orbits. Over billions of years, the Milky Way grows by a process that is both gentle and violent. Small satellite galaxies, drawn in by gravity, begin to spiral closer. At first, they stretch and distort. Their stars form long streams, wrapping around the Milky Way like faint ribbons of light. Eventually, these smaller galaxies dissolve completely, their stars becoming part of the galactic halo. This process is happening right now. The Sagittarius dwarf galaxy, for example, has been interacting with the Milky Way for billions of years. Each time it passes through the galactic disk, it loses more of itself. Its stars are slowly being absorbed, becoming indistinguishable from the rest of the Milky Way's population. To the galaxy, this is not destruction. It is nourishment, a quiet form of growth. The Milky Way does not consume in a hurry. It waits. It pulls gently, but persistently. Time is always on its side. Even the gas between galaxies is not empty. It is thin, cold, and diffuse. But over immense timescales, gravity can gather it. This intergalactic gas feeds the galaxy, ensuring that star formation does not simply stop. Without this slow inflow of material, the Milky Way would have used up its star-forming gas long ago. The night sky would be darker. New suns would be rare. The galaxy would feel old and quiet. Instead, the Milky Way continues its steady rhythm of birth and change. Stars form in giant molecular clouds, deep within the spiral arms. These clouds collapse under their own gravity, fragmenting into dense cores. Where nuclear fusion ignites, young stars shine brightly, lighting up their surroundings and shaping the structure of the galaxy. Over time, those stars drift away. Some remain stable for billions of years. Others exhaust their fuel and fade into white dwarfs, neutron stars, or black holes. Their remnants remain, quietly orbiting the galactic center, contributing to the Milky Way's mass and gravity. The galaxy remembers every stage of its growth. Its oldest stars, found mostly in the halo, preserve chemical signatures from the early universe. They contain very little of the heavier elements forged in later generations of stars. By studying them, astronomers can reconstruct the Milky Way's childhood. Meanwhile, younger stars in the disk tell a different story. They are richer in heavy elements. They often host planets. Some of those planets may resemble Earth, orbiting calmly within the habitable zones of their stars. All of this complexity arises from a process that never truly stops. The Milky Way is not finished building itself. Even its central supermassive black hole, Sagittarius A*, plays a role in this slow evolution. Though currently quiet, it occasionally feeds on gas that drifts too close. In the distant past, it may have been far more active, shaping the inner regions of the galaxy with powerful outflows of energy. Growth in the Milky Way is not always visible. Much of it happens in darkness, through gravity, through time. When you consider this, daily concerns can begin to soften. The galaxy has been growing for billions of years without urgency. Nothing in its story is rushed. Everything unfolds at its own natural pace. As you rest now, your body mirrors that rhythm. Breath in, breath out. Slowly, effortlessly. You are part of this galaxy's story, carried along by its motion, even as you lie still. The Milky Way will continue to grow long after human history fades. It will merge with Andromeda. Its shape will change. New stars will rise. Others will quietly disappear. Yet even in those distant futures, the process will remain the same. A calm, persistent gathering of matter, a never-ending transformation. There is no final form the Milky Way is trying to reach. Only balance, only motion, only time. And as this thought settles, you can allow your awareness to drift gently onward, knowing that just as the galaxy grows without strain, you too can rest without effort, floating quietly within a universe that has all the time it needs. If the Milky Way is a living system, always growing and changing, then its spiral structure is the visible expression of that motion, a soft signature written in stars, gas, and dust. Elegant, yet never fully revealed. From Earth, embedded deep within one of its arms, the Milky Way does not appear as a spiral at all. It stretches across the night sky as a pale, milky river of light, a faint glow, a quiet reminder that we are inside the structure we are trying to understand. This position gives us intimacy, but it also limits clarity. Unlike distant galaxies, which we can observe from the outside, the Milky Way surrounds us. Its core is veiled behind vast clouds of cosmic dust. These microscopic grains, scattered between the stars, absorb visible light and blur our view, especially toward the dense central regions. Because of this, one of the most basic questions about our home galaxy remains open. How many spiral arms does the Milky Way truly have? For many years, astronomers believed the answer was simple. 4 large, well-defined spiral arms, winding outward from the galactic center like a cosmic pinwheel. Names were given, maps were drawn. The structure felt orderly and reassuring. But as technology improved, certainty began to soften. Infrared telescopes allowed scientists to peer through dust that once blocked their vision. Radio observations traced cold hydrogen gas spread across the galactic disk. Star-forming regions were mapped with increasing precision, and what emerged was not a rigid pattern, but something more subtle. Some observations still support the idea of 4 major arms. Others suggest only 2 dominant arms, with additional spurs and branches extending between them. Instead of a clean design, the Milky Way may possess a fragmented, layered spiral, one that shifts gently over time. In this way, the galaxy reflects the process described earlier: growth without fixation, structure without stiffness. Spiral arms are not solid objects. They are not permanent walls of stars. They are waves, much like ripples, moving across the surface of a calm lake. Spiral arms are density waves, regions where stars and gas bunch together slightly as they orbit the galactic center. As material enters these denser regions, gas clouds compress. Stars are born. Light flares briefly brighter. Then, over millions of years, those stars drift onward, leaving the spiral arm behind. The arm itself persists, but its contents are always changing. This means that the Sun, and Earth with it, is not fixed in one arm forever. Over long timescales, our solar system moves in and out of these spiral regions, sometimes passing through active star-forming zones, at other times drifting through quieter, darker stretches of the disk. There is a softness to this idea. Nothing is locked in place. Everything participates in motion. The Milky Way's spiral structure is shaped not only by gravity and rotation, but also by its past encounters. As smaller galaxies are absorbed, their gravitational influence can disturb the disk. Waves ripple outward. Arms stretch, split, or reconnect. Even giant clouds of gas can tug gently on the spiral pattern, subtly reshaping it over time. Because of this, the Milky Way's spiral arms are not identical from one rotation to the next. They evolve, they breathe, they respond. In some regions, arms appear strong and well-defined, packed with glowing nebulae and young blue stars. In others, they fade into wisps, thin streams of stars barely brighter than the surrounding darkness. Our own location, within the Orion Spur, reflects this complexity. We do not reside in one of the galaxy's largest arms, but in a quieter branch between them, a gentle neighborhood, less crowded, less turbulent. This may not be a coincidence. Regions closer to major spiral arms experience more frequent supernovae, higher radiation levels, and greater gravitational disturbances. Quieter regions may offer a more stable environment for planets, and for life to persist over long periods. Again, the galaxy does not rush. It does not optimize in haste. It allows variety. When scientists debate the number of spiral arms, they are not disagreeing over a mistake. They are observing a system that refuses to be pinned down to a single snapshot, a structure defined by motion rather than boundaries. And perhaps this uncertainty is fitting. After all, the Milky Way is not meant to be fully grasped at once. It reveals itself gradually, as instruments improve and as patience deepens. Each new map is not a correction of the past, but an addition to a growing understanding. As you rest now, you can imagine the galaxy turning slowly around its center, spiral arms gently curving, stars gliding through invisible pathways. dust drifting like a cosmic fog, softening the light. Nothing sharp, nothing abrupt, just a vast, rotating calm. The same calm that carried the Milky Way through billions of years of growth now carries this moment. And as the spiral structure continues its quiet dance, you are free to let your thoughts loosen, allowing them to follow the curve of the galaxy, drifting, unhurried, toward deeper rest. Hidden within the Milky Way's vast disk and faint halo are stars that do not truly belong to its original design. They move differently. They carry unusual chemical signatures. And most remarkably, they were born before the Milky Way became what it is today. These are stars, older than the galaxy itself. While the spiral structure continues to shift and reshape over billions of years, these ancient stars remain quiet witnesses to a far earlier universe, a time when galaxies were small, fragile, and still learning how to exist. Shortly after the Big Bang, the universe was a simpler place. There were no planets, no heavy elements, only hydrogen, helium, and traces of lithium drifting through expanding space. The first stars formed from this pristine material. They were massive, short-lived, and powerful. When they died, they forged the first heavier elements: carbon, oxygen, iron, seeding the cosmos with the raw ingredients for future generations of stars. Some of those early stars formed inside small, primitive galaxies. These tiny systems moved slowly through space, eventually drawn toward larger structures by gravity. Over time, the growing Milky Way absorbed them. When this happened, their stars were not destroyed. They were quietly incorporated, scattered into elongated orbits, lifted above and below the galactic disk, placed gently into the halo that surrounds the Milky Way today. This is why some stars feel out of place. They orbit the galaxy at odd angles. They move faster or slower than expected, and their chemical composition reveals their age. Astronomers can read these chemical fingerprints like a cosmic diary. Ancient stars contain very little metal elements heavier than helium, because they formed before the universe had time to enrich itself. They are simple, pure, unadorned. In this way, they are often called living fossils, not because they are frozen in time, but because they preserve information that would otherwise be lost. Each one is a message from the early universe, still shining softly billions of years later. Some of these stars may be more than 13 billion years old, almost as old as the universe itself. They have survived the violent youth of the cosmos. They have witnessed the formation of spiral arms, the ignition of countless suns, and the slow assembly of the galaxy around them. While the Milky Way's spiral structure continues to evolve, arms forming, dissolving, and reforming, these ancient stars remain largely unchanged. Their nuclear fires burn slowly, steadily, patiently. There is something deeply calming in this contrast. On one level, the galaxy is dynamic and restless. Arms rotate, gas collapses, stars are born and die. On another level, time stretches so far that change becomes gentle, almost imperceptible. These ancient stars remind us that not everything needs to rush, that endurance can be quiet, that survival does not require spectacle. As you imagine them now, scattered throughout the halo, you can picture them as faint lanterns surrounding the galaxy, soft points of light, drifting far above the spiral arms, unconcerned with the details of structure below. They are not part of the pattern, they are part of the memory. And just as the Milky Way carries these ancient stars within it, you carry memories of your own experiences gathered across years, quietly shaping who you are now. There is no need to examine them tonight, no need to organize or resolve them. Like those stars, they can simply exist, calm, unchanging, safe within a larger structure that continues to move on your behalf. The galaxy turns, the spiral arms glide, and the oldest stars keep watch. All of it unfolding slowly, while you are free to rest. The Milky Way does not rest. It turns, slowly, endlessly, like a vast cosmic river. Our solar system is carried along within this motion, drifting through space at an astonishing speed, about 828,000 kilometers per hour. Yet despite this incredible velocity, the journey feels gentle, so gentle that we never sense it at all. This is the calm illusion of cosmic scale. To complete a single orbit around the center of the Milky Way, the Sun needs nearly 225 million years, one full journey, one galactic year. Since its birth, the Sun has completed only about 20 of these immense cycles, 20 quiet loops around a distant core filled with stars, gas, and a supermassive black hole hidden behind curtains of dust. Compared to a human lifetime, this motion is unimaginably slow. Compared to the age of the universe, it is a steady, patient rhythm. As the solar system travels, it passes through different regions of the galaxy. Spiral arms rich with gas and newborn stars, quieter interarm spaces where the night grows darker and calmer, invisible waves of gravity gently guiding everything along its path. The planets come with us. The Earth comes with us. Every memory you have ever formed has happened while moving through space at this silent speed. You have never been still, and yet you have always felt grounded. This is one of the most comforting truths astronomy offers. Motion does not mean instability. Movement does not mean danger. The galaxy carries us smoothly, like a cradle in slow rotation. The galactic year reminds us that time does not need to hurry. That progress can be measured in millions of years. That growth can be almost imperceptible and still be real. Those ancient stars we imagined before, older than the galaxy itself, are also part of this motion. They trace long, graceful orbits, rising far above the galactic disk and dipping back down again, like slow breaths taken over eons. Everything participates. Nothing is rushed. As you lie here now, breathing quietly, your own rhythm mirrors this cosmic motion. Inhale, exhale, a gentle cycle, no urgency, no destination that must be reached tonight. The Milky Way will complete its orbit whether you watch or not. The Sun will continue its long journey. The stars will keep their steady paths. You do not need to keep track of time. You do not need to measure progress. For this moment, it is enough to simply drift, carried by a galaxy that has been moving calmly for billions of years and will continue long after sleep finds you. Far beyond the gentle order of planetary systems, away from the warmth of any star, there exist worlds that travel alone. They are called rogue planets, sometimes named orphan planets, sometimes described as wanderers. These are planets that do not orbit a sun. They drift freely through the Milky Way, silent and unseen, moving through the darkness between stars. Their journeys often begin in crowded places, young star systems, where gravity pulls in many directions at once. Newborn planets circling close together, their orbits delicate, still forming, still uncertain. In these early moments, chaos is common. A close encounter, a slight gravitational nudge, a powerful interaction with a giant planet or passing star, and suddenly, one world is pushed away, slowly at first, then faster, until it escapes the gravitational embrace of its home star entirely. Once free, there is no turning back. The planet drifts into interstellar space, where darkness stretches for trillions of kilometers, and the nearest star may be light years away. At first, the planet may still glow faintly, leftover heat from its violent birth, residual warmth trapped deep within its core. But over time, that warmth fades, the surface cools, the atmosphere thins or freezes. Oceans, if they ever existed, turn to solid ice beneath a black sky, and yet the planet continues. It moves along its own path, through the galaxy, following the same gravitational currents that guide stars and nebulae, just quieter, more solitary, Astronomers believe there may be billions of rogue planets in the Milky Way, perhaps even more than the number of stars. They are everywhere, and almost nowhere at once. We cannot see them easily. They do not shine. They do not reflect much light. Most are discovered only when they pass briefly in front of a distant star, bending its light through gravity, creating a soft, temporary signal, a whisper that says, something is there. For a moment, the invisible becomes known, then it slips back into darkness. From a human perspective, the idea of a wandering planet may feel lonely. A world without sunrise, without seasons, without a familiar sky. But in the language of the cosmos, there is no loneliness, only motion. These planets are not lost. They are simply following a different rhythm. Some rogue planets may still carry internal heat for billions of years, enough to keep subsurface oceans liquid beneath thick layers of ice, enough to allow chemistry to continue, quietly, unseen. In the deepest darkness, possibility remains. Life, if it exists there, would never know a star, never see light fall from a sky, never experience day or night. And yet, it could still persist, nurtured by warmth rising slowly from a planetary core, protected beneath ice like a cosmic blanket. This thought changes the meaning of isolation. It reminds us that connection does not always require light. That stability does not always require proximity. That existence itself can be enough. As the galaxy turns, rogue planets move with it. They share the same galactic orbit as stars, the same long journey around the Milky Way's center, the same invisible pull of dark matter and gravity. They are not separate from the galaxy. They are part of its quiet background, a hidden population drifting between luminous points, much like thoughts that drift through the mind at night, not attached to anything, not demanding attention, just passing. If you imagine yourself riding along with one of these planets, the experience would be profoundly calm. No blinding light, no sudden change, only a slow, steady movement through space. Stars would appear as distant pinpricks, barely shifting over thousands of years. The galaxy itself would feel vast, but not overwhelming. Time would stretch. Moments would blur together. Urgency would dissolve. In this way, rogue planets offer a quiet lesson. They show us that it is possible to move forward, without noise, without pressure, without expectation. They remind us that not every journey needs a destination. Earlier, we spoke of the galactic year, the long orbit of the Sun, around the Milky Way's heart. A journey so slow it feels like stillness. Rogue planets share that same timescale. They, too, complete these enormous orbits. Even if they travel alone, they are carried by the galaxy just as we are. As you listen now, your body rests in one place, but the Earth moves beneath you. The Sun carries us onward. The Milky Way turns, and somewhere far away, countless dark worlds drift peacefully through space, unaware of names, unaware of meaning, simply existing. There is something deeply soothing in that thought. Nothing is required of them. Nothing is demanded. They are allowed to be. In the same way, you do not need to solve anything tonight. You do not need to plan. You do not need to arrive. Like a rogue planet, you are permitted to drift, to let the mind loosen its grip, to release the weight of the day, to move gently toward rest, guided not by force, but by the quiet gravity of sleep. The galaxy has room for wanderers, and tonight, so does this moment. In the vast calm of space, there exist stellar partnerships where two stars are locked in orbit, circling one another endlessly. Their gravitational dance, lasting millions or even billions of years. These are known as binary star systems. From a distance, they may look peaceful, two points of light moving in slow harmony. But up close, their interactions can be among the most dramatic phenomena in the universe. In some binary systems, the two stars are not equals. One may be young and swollen with gas. The other may be ancient, dense, and incredibly compact. A white dwarf, the burned-out core of a once sun-like star. A neutron star, so dense that a single teaspoon of its material would outweigh a mountain. Or even a black hole, where gravity becomes so strong that not even light can escape. When such an object orbits close to a normal star, its gravity begins to pull, slowly at first, almost imperceptibly. Gas from the companion star stretches outward, forming a delicate stream, spiraling toward the denser object. This process is called stellar accretion. To the human mind, it may sound violent, and in many ways, it is. But in the universe, it is also natural. As the stolen material falls inward, it does not disappear immediately. Instead, it forms a glowing accretion disk, a flattened ring of gas and plasma, rotating at extraordinary speeds. Friction within the disk heats the material to millions of degrees. It begins to shine intensely, not in gentle starlight, but in X-rays and high-energy radiation. From far away, these systems appear as some of the brightest X-ray sources in the galaxy, invisible to human eyes, yet powerful beyond imagination. The companion star slowly loses mass. Its outer layers are peeled away over time, like mist drawn toward a fire. This is why astronomers sometimes call these systems cannibal stars, one star feeding on another. Yet even here, there is no malice, no intention, only gravity, doing what gravity always does. In some cases, the transfer of material is steady and calm. In others, it becomes unstable. Gas piles up on the surface of a white dwarf, compressed tighter and tighter until nuclear fusion suddenly ignites. The result is a nova, a sudden, brilliant flash of light that can briefly outshine entire star systems. And then, after the outburst fades, the quiet feeding resumes. In rarer situations, the consequences are even more dramatic. If a white dwarf steals too much material, it can reach a critical mass. At that moment, it explodes completely in a Type Ia supernova, destroying itself in a single, blinding event. For a few weeks, it shines brighter than billions of stars combined. And then, it is gone. These explosions seed the galaxy with heavy elements: iron, nickel, gold. The atoms in your blood, the minerals in the earth beneath you, were forged in moments like these. Even destruction in the universe leads to creation. Black holes in binary systems create their own kind of calm intensity. As matter spirals inward, it accelerates to near light speeds. Magnetic fields twist. Jets of energy erupt from the poles, shooting far into space. Yet despite the violence near the event horizon, the black hole itself remains silent. No explosion, no sound, only a steady presence, shaping space and time around it. From a certain perspective, these systems reflect something deeply familiar. They show us how closeness amplifies everything, how proximity can transform gentle forces into overwhelming ones. In daily life, pressure often builds not from distance, but from being too close, to expectations, to responsibilities, to constant motion. Binary stars remind us that space matters. That balance depends on distance. When stars orbit at the right separation, they coexist peacefully for eons. Too close, and the relationship changes. Tonight, as your breathing slows, there is no need to hold everything tightly. You can allow space to exist. The universe itself does. As we move from wandering rogue planets to these intense stellar pairs, we see the full range of cosmic connection, from complete solitude to unavoidable entanglement, and both are part of the same galaxy. The Milky Way holds quiet drifters and blazing partnerships alike. It makes room for stillness and for transformation. As you rest now, you can imagine floating between stars, far from the pull of any strong gravity, where nothing is taken and nothing is demanded, just gentle motion, just time. Let the day loosen its grip. Let the mind soften. The stars will continue their dance without you watching. The galaxy will turn, patient and vast, and you are allowed, in this moment, to simply rest. When astronomers first began to carefully measure how the Milky Way rotates, they expected the galaxy to behave like a familiar system, much like planets orbiting the sun, or like a spinning disk slowing toward its edges. According to classical Newtonian physics, objects farther from the center should move more slowly, held by weaker gravitational pull. But the Milky Way did not obey this expectation. Stars near the outer edge of the galaxy were moving, just as fast as stars much closer to the center. The farther scientists looked, the stranger it became. By all visible measures, there simply was not enough mass to hold the galaxy together. Based only on the stars, gas, and dust we can see, the Milky Way should have torn itself apart billions of years ago. And yet, it remains calm, stable, enduring. Something invisible was providing extra gravity, something vast and silent. This is how dark matter entered the story. Dark matter does not glow. It does not reflect light. It does not emit radiation. It passes through space and through us without interaction. And yet, its gravity is real. It shapes galaxies. It bends light. It forms the unseen skeleton upon which cosmic structures are built. Astronomers estimate that dark matter makes up about 85% of all matter in the universe. Everything we see, stars, planets, nebulae, dust, is only a small fraction of what actually exists. The Milky Way is embedded within a vast halo of dark matter, extending far beyond its luminous spiral arms. This halo is spherical, diffuse, and enormous. It surrounds the galaxy like an invisible ocean, its presence known only through gravitational effects. As the galaxy rotates, stars move as if guided by an unseen hand, their paths smoothed and stabilized by this dark, silent mass. Without it, the spiral arms would unravel, stars would drift away, order would dissolve. Dark matter does not rush, it does not collide, it does not clump in the way normal matter does. It simply exists, everywhere, patiently. In many ways, dark matter is the quietest force in the universe, and yet, without it, there would be no galaxies, no Milky Way, no long-lived spiral structure, no stable environment for stars and planets to form. Dark matter allowed the universe to grow slowly rather than collapse or disperse too quickly. It created wells of gravity where gas could gather, cool, and ignite into stars. Even before the first stars ever shone, dark matter was already there, shaping the cosmos. It is ancient beyond imagination, older than light, older than atoms, older than the Milky Way itself. And still, we do not know what it is. Scientists have proposed many ideas: exotic particles, weakly interacting matter, entire new categories of physics. But for now, dark matter remains elusive, undetectable directly, untouchable, unseen. It reminds us that the universe does not reveal itself all at once. Some truths move slowly, some foundations remain hidden, and that is not something to fear. As we lie here, listening quietly, dark matter is passing through this room, through the earth, through your body, not in any harmful way, not with force, just passing as it always has. You do not feel it, you do not notice it, and yet it is part of what allows the galaxy to exist, and therefore part of what allows you to exist. There is something deeply comforting in that idea, that not everything important must be seen, that not everything essential announces itself. Much like rest, sleep, too, is invisible. You cannot hold it. You cannot force it. But when it arrives, it holds you. Dark matter teaches us about trust. The stars trust it without knowing its nature. They move calmly through space, confident that something unseen will keep them on their paths. You can do the same tonight. You do not need to understand everything. You do not need to solve the mysteries of the day. You can allow yourself to be supported by rhythms older than thought. The Milky Way continues to rotate, once every few 100 million years, guided by a balance we cannot fully explain. Yet it works. It has worked for billions of years. As we move forward from cannibal stars and intense gravitational bonds, dark matter offers a contrast. Not forceful, not dramatic, but constant. It does not consume, it does not explode. It simply holds. As your breathing becomes slower, as your thoughts become softer, imagine yourself within that invisible halo, carried gently, stabilized quietly, protected by something you do not need to see. The galaxy does not rush, neither do you. Everything that needs to turn will continue turning. Everything that needs to rest is allowed to rest now. When we look up at the night sky, we see only a thin slice of reality, a soft scattering of stars, a faint, milky band stretching across the darkness, points of light that feel calm and distant. But this visible glow is only the surface. Beneath it, around it, and flowing through it, the Milky Way is alive with energy. Not the kind our eyes can see, but the kind that fills space continuously, like a slow, endless song. This is the invisible symphony of radiation. Every moment, the galaxy hums with waves of energy moving at the speed of light. Radio waves drifting gently across vast distances. X-rays flashing briefly from violent events. Gamma rays whispering of extreme forces near black holes. Cosmic rays raining softly through space, sometimes passing quietly through your body without notice. All of it together forms a cosmic orchestra, playing far beyond the range of human senses. Radio waves are the deepest notes of this symphony. They come from enormous clouds of hydrogen gas, slowly rotating with the spiral arms, from the gentle motion of electrons spiraling around magnetic fields, from the quiet afterglow of ancient supernovae. Radio waves are calm. They travel easily through dust and darkness. They reveal the structure of the galaxy, even where starlight cannot reach. Through radio astronomy, we have mapped spiral arms hidden behind thick cosmic dust. We have traced the gentle breathing of interstellar clouds, expanding and contracting over millions of years. Radio waves remind us that softness can still carry information, that quiet signals can travel the farthest. Higher in energy, the galaxy begins to glow in infrared. Infrared light reveals warmth. Not heat like fire, but the gentle warmth of dust grains, heated by nearby stars. These grains drift slowly through space, absorbing starlight, then releasing it as infrared radiation. In this invisible glow, we see star nurseries, cold regions where gravity is gathering material, places where future suns are forming quietly, still wrapped in protective cocoons of gas and dust. Infrared light shows us beginnings. It shows us potential, before anything shines brightly. Moving further up the spectrum, we encounter ultraviolet light. This radiation comes from hot, massive stars, young and powerful, burning their fuel rapidly. Ultraviolet light sculpts the galaxy. It carves cavities in gas clouds. It shapes nebulae into glowing arches and pillars. It signals places of intense activity and short-lived brilliance. These stars live fast. They shine fiercely, and they fade quickly. Their radiation is strong, but brief. Then come X-rays. X-rays tell stories of extremes. They come from the remnants of exploded stars, from neutron stars spinning hundreds of times per second. from accretion disks around black holes, where matter is heated to millions of degrees. X-rays do not linger, they burst, they flare, they fade. Each X-ray photon carries the memory of violence, of matter accelerated beyond normal limits. And yet, even these intense signals are part of the galaxy's balance. They distribute energy, they influence surrounding gas, they help regulate star formation. Nothing here is wasted. At the highest energies of all, there are gamma rays. Gamma rays are rare, but powerful. They emerge from supernova explosions, from the annihilation of particles, from the edges of black holes where physics itself begins to bend. Some gamma ray bursts are so energetic that they briefly outshine entire galaxies, even from billions of light years away. And still, the Milky Way absorbs and disperses these events without disruption. Like a vast ocean, it allows even the most intense waves to pass through without breaking its form. Finally, there are cosmic rays. These are not waves of light, but actual particles, protons, electrons, atomic nuclei, accelerated to incredible speeds. They originate from supernova shocks, from energetic stellar winds, from distant galaxies. They rain gently upon Earth every moment, passing through the atmosphere, through walls, through your body. You do not feel them. You do not notice. They are simply part of the background of existence. Together, all these forms of radiation create a symphony that never stops playing. It does not follow a melody we can hum. It does not repeat itself exactly. It evolves. As stars are born, the music changes. As stars die, new instruments join the orchestra. As the galaxy slowly rotates, the rhythm shifts over millions of years. And through it all, dark matter holds the stage steady, ensuring that the performance continues. What is most remarkable is that all this energy exists without chaos. Despite the violence of supernovae, despite the intensity of black holes, the galaxy remains calm on large scales. Radiation flows outward, energy disperses, balance is maintained. This is not noise, it is harmony. And just as the galaxy contains invisible energy, so does the human mind. Thoughts move like waves. Memories flare briefly like X-rays. Worries arrive suddenly, like gamma rays, then pass. Most of the time, these inner signals are not harmful. They are simply energy moving through awareness. Tonight, you do not need to block them. You do not need to analyze them. You can allow them to pass, the way the galaxy allows radiation to pass, without resistance, without judgment. Earlier, we spoke of dark matter, the unseen structure that holds everything together. Now we see its counterpart, unseen energy that flows freely within that structure. One provides stability, the other provides motion. Together, they allow the Milky Way to live. As your body rests, you are surrounded by invisible waves as well. Radio signals, thermal radiation, soft electromagnetic noise. None of it requires attention. Your nervous system understands how to filter, how to settle, how to rest. The galaxy does not react to every signal. It responds only to what matters on long timescales. You can do the same. Let the intense thoughts fade like distant gamma rays. Let gentle sensations drift like radio waves. Let awareness soften. Somewhere in the Milky Way, a star is ending its life in a quiet supernova. Somewhere else, a cloud of gas is beginning to collapse, starting a new cycle. And here, in this moment, you are safe, held by gravity, surrounded by quiet energy, part of a universe that knows how to balance motion and rest. The symphony continues, whether you listen or not. You do not need to stay awake for it. You can let the music play on its own as you drift gently towards sleep. In our everyday imagination, a planet orbits a star, a simple picture, a single path traced again and again. But the universe enjoys variety. In some rare and beautiful cases, two planets orbit each other. These are known as binary planets. Rather than one world dominating the other, both bodies circle a shared center of gravity, called a barycenter. From afar, they appear as a paired system, moving together through space, their motions synchronized and intimate. They do not chase. They do not collide. They balance. Each planet tugs gently on the other, their gravitational connection forming a stable dance that can last billions of years. One world rises in the sky of the other, large and close, never far away. If you stood on the surface of such a planet, you would see your companion world suspended above the horizon, slowly shifting position, never fully setting. There would be no true loneliness there, only presence. Astronomers believe that some binary planets may form when two planetary bodies grow together from the same disk of material. Others may result from close encounters, where gravity captures and binds them into partnership. These systems are delicate. They require balance. Too much disturbance, and the pair separates. But when conditions are right, they persist. Binary planets remind us that stability does not always mean simplicity. Sometimes, balance is shared. Sometimes, support is mutual. This idea echoes softly within the galaxy itself, where not only planets, but stars also show unexpected forms. Most stars appear round, their gravity pulling matter evenly toward their centers. But some stars rotate very, very fast. So fast that gravity can no longer maintain a perfect sphere. These stars begin to flatten. Their equators bulge outward. Their poles compress inward. They become oblate, wider than they are tall. This rapid rotation creates striking consequences. The equator, stretched farther from the center, experiences weaker gravity. It becomes cooler, darker. The poles, closer to the core, remain hotter and brighter. This effect is known as gravity darkening. The star no longer shines evenly. Its light is unevenly distributed, stronger at the poles, gentler at the equator. From space, such a star looks subtly distorted, like a spinning drop of liquid frozen in motion. This is not a flaw. It is a record, a visible memory of motion, etched into the star's shape. Rotation shapes destiny in the universe. It determines how stars age, how they mix their internal layers, how they lose mass through stellar winds. Fast-spinning stars live differently from slow ones. Some burn brighter and shorter. Some eject material into surrounding space, enriching the galaxy with elements. Once again, we see that motion does not create chaos by default. It creates diversity. Binary planets show us shared gravity. Flattened stars show us the imprint of speed. Both remind us that the universe does not demand perfection. It allows variation. As we drift mentally from the invisible radiation of the galaxy to these paired worlds and spinning stars, the transition feels natural. Energy flows, motion responds, shapes change. Nothing is forced. Nothing resists. The galaxy adapts. In human life, we often seek to maintain a fixed shape, a fixed role, a fixed pace. But the cosmos shows us another way. It shows us that being shaped by motion is not a failure. It is a sign of participation. Binary planets do not lose themselves by orbiting together. They gain stability through connection. Rapidly spinning stars do not break under speed. They transform. Tonight, you do not need to be perfectly balanced. You do not need to be perfectly still. You are allowed to have edges that soften, areas that glow more gently, moments where energy redistributes, just like the stars. As you rest now, imagine floating near a binary planet system, two worlds turning slowly around each other, their gravity calm and predictable, their motion soothing to watch. Above them, A slightly flattened star shines, brighter at its poles, cooler at its equator. Nothing is wrong here. Everything is simply responding to motion. Your breath follows a similar pattern. Inhale, exhale, a gentle exchange, a shared rhythm between body and rest. You are not separate from these cosmic patterns. You are an echo of them. Earlier, the galaxy hummed with invisible radiation. Before that, dark matter held everything together. Before that, stars shared intense gravitational bonds, and planets wandered alone. Now, we see companionship and transformation. All of it belongs. As the Milky Way continues its slow rotation, it carries binary planets, flattened stars, and quiet observers like you. Along the same vast orbit, nothing rushes. Nothing demands attention. The universe does not need you to stay awake to function. You can let your thoughts slow, like a star, easing its spin over time. You can let awareness soften, like gravity redistributing itself gently. The dance continues without effort, and you are free, in this moment, to rest within it. The Milky Way feels calm tonight. Its spiral arms rotate patiently. Its stars follow ancient paths. Its gas clouds glow faintly, almost breathing. But this serenity is not the absence of change. It is the result of change, slow, immense, and beautifully irreversible. Long before the sun ever formed, before Earth had oceans or skies, the Milky Way was already shaped by encounters far beyond imagination. Galaxies are not isolated islands. They drift through space in loose communities, bound by gravity across millions of light years. Over cosmic time, their paths cross. And when galaxies meet, they do not collide like stones. They merge. In the early universe, small proto-galaxies formed first. Collections of gas, dust, and dark matter, slowly condensing after the Big Bang. These early structures were restless. They orbited, approached, and were drawn together. The Milky Way grew by absorbing smaller galaxies, one after another, over billions of years. Some were torn apart completely, their stars stretched into long streams, still visible today as faint arcs, wrapping around our galaxy. Others left behind dense cores, globular clusters, ancient groups of stars, older than almost anything else we know. Every such merger left a trace, a subtle shift in motion, a ripple in stellar orbits, a quiet memory written into the halo of stars surrounding the Milky Way. Our galaxy is not a single creation. It is a collection of histories layered patiently over time. Even now, the Milky Way is still consuming. The Sagittarius dwarf galaxy, a small companion, is currently being pulled apart, its stars gradually becoming part of us. This process is slow, so slow that no living being could notice, yet it never stops. Galaxies are shaped not by sudden violence, but by prolonged intimacy. This brings us, inevitably, to Andromeda. The Andromeda galaxy lies about 2.5 million light-years away. From Earth, it appears as a faint, elongated glow, the most distant object visible to the naked eye. For centuries, it seemed static, a quiet neighbor. But precise measurements reveal something astonishing. Andromeda is moving toward us, very slowly, about 110 kilometers per second. At first, this sounds fast, but on a cosmic scale, it is a whisper. Still, gravity is patient. In approximately 4.5 billion years, the Milky Way and Andromeda will begin a long, graceful encounter. Their outer halos will touch first. Dark matter will intertwine. Stars will pass one another, without collision. Vast distances still separating them. Despite the word collision, individual stars almost never crash. Space is simply too large. Instead, the galaxies stretch. Their spiral arms elongate, Tidal forces draw out luminous streams of stars and gas, arching across space like slow-motion waves. Over hundreds of millions of years, the two galaxies will orbit each other, approach, separate slightly, then return. Each pass reshapes them. Gas clouds compress, triggering new bursts of star formation. Brilliant blue stars ignite, live briefly, and fade. Eventually, after several such encounters, the two galaxies will settle into one, a single, larger galaxy, often called Milkomeda by astronomers. It will likely be elliptical in shape, smoother, less structured. The Sun, if it still exists by then, may find itself in a very different region of space. The night sky of future Earth, if Earth still remains, would be unrecognizable. Andromeda would grow larger each night, spreading across the sky until it dominates everything, not as a threat, but as a presence. This future is not sudden. It is not catastrophic. It is slow enough to be considered gentle. Galactic mergers are not endings. They are transformations. In fact, many of the large, elegant galaxies we observe today are the results of ancient mergers. Their smooth shapes are the final calm. After long gravitational conversations, this knowledge carries a quiet comfort. Even on the largest scales, nothing is wasted. Destruction becomes structure. Disruption becomes renewal. The stars formed during these mergers carry heavier elements: carbon, oxygen, iron, the building blocks of planets, and life. Without galactic collisions, the universe would be simpler, but poorer. The Milky Way's past collisions are the reason planets like Earth exist at all. Earlier, we spoke of binary planets sharing gravity, of stars reshaped by rotation. Now we see the same principle, expanded across millions of light years, balanced through interaction, formed through motion. Even galaxies need companionship. As you rest now, it may be comforting to realize how slow this future truly is. 4.5 billion years, longer than any worry could survive, longer than any unfinished thought. The universe does not rush toward its destiny. It drifts. You do not need to stay alert for what comes next. The cosmos will still be here when you are asleep. Imagine the Milky Way and Andromeda approaching one another in near silence. No sound, no shockwave, only gravity drawing two vast spirals together, like distant memories finally meeting. Stars pass like lanterns in the dark. Gas clouds glow softly. Dark matter embraces invisibly. Nothing is lost. Everything changes. Your mind can follow this same pattern now. Thoughts approach. They overlap. They dissolve. You do not need to hold on to them. Just as galaxies merge without effort, your awareness can blend gently into rest. Earlier, we listened to invisible radiation. We traced dark matter's quiet grip. We watched planets dance and stars flatten. Now, we stand at the scale of eternity. And even here, the lesson remains simple. Change does not mean danger. Movement does not mean urgency. Sometimes, the most profound events take billions of years and feel like calm. As the future Milky Way slowly reshapes itself, you are free to let go of the need to anticipate. The universe has already done that for you. It carries the past. It prepares the future. It does not ask you to stay awake. You can rest now, knowing that even galaxies take their time, and sleep, like gravity, will gently draw everything to where it needs to be. Long before the Milky Way learned how to grow, long before spiral arms traced luminous paths across space, the universe was filled almost entirely with one element: hydrogen. It was everywhere, thin, evenly spread, unremarkable at first glance. Yet within this simplicity rested all future complexity. Hydrogen formed just minutes after the Big Bang, when the universe had cooled enough for protons and electrons to gently combine. No planets yet, no stars, no galaxies, only an expanding ocean of invisible gas, cooling, drifting, waiting. Some of that hydrogen has never truly changed. Even today, astronomers detect vast clouds of primordial hydrogen, regions of space so isolated, so untouched, that their chemical makeup remains almost identical to the universe's earliest moments. These clouds are not bright. They do not glow dramatically. They are quiet reservoirs of memory. They float between galaxies or at the very edges of galactic halos where few stars disturb them, and time moves slowly. To study them is to look backward, not just millions, but billions of years. They whisper of a universe before structure, before violence, before differentiation. Hydrogen is the universe's first breath, and it is also the fuel for nearly every star that ever lived. When gravity gathers hydrogen into denser and denser regions, temperature rises, pressure builds, and at a critical moment, fusion begins. Hydrogen atoms merge into helium, releasing light, heat, and time. A star is born. For millions, sometimes billions of years, a star exists in balance. Gravity pulls inward, fusion pushes outward. A quiet agreement, but no agreement lasts forever. Eventually, hydrogen runs low, the core changes, and the star must decide, not consciously, but inevitably, how it will end. Many people imagine stellar death as something explosive, a brilliant supernova, a flash brighter than an entire galaxy. And sometimes this is true, but the universe also allows another kind of ending, a silent one. Some of the most massive stars do not explode at all. When their fuel is exhausted, their cores collapse under gravity so intense that not even light can escape. There is no dramatic outward blast, no cosmic announcement. The star simply disappears. Its outer layers fall inward. Space closes. A black hole is born without spectacle. Astronomers call these events failed supernovae. From a distance, they look like stars that simply fade away. One night, the star is there. The next, it is not. No fireworks, no lingering glow, just absence. This kind of death feels almost gentle, and perhaps it is. The universe does not insist on noise. It does not demand witnesses. Some transformations happen in perfect quiet. The matter of that star, hydrogen fused into heavier elements, then crushed beyond recognition, is not lost. It becomes part of the black hole's mass, deepening the curvature of space itself. Even silence has weight. This idea connects softly to what we explored before. Galactic mergers reshape structure. Dark matter guides rotation invisibly. Radiation sings without sound. Now we see that even death, on a stellar scale, can be understated. Just as galaxies merge without collision, stars can end without explosion. Not every ending needs to be dramatic. Primordial hydrogen clouds and silent stellar deaths represent two extremes of time, one at the very beginning, one at the very end, and yet they are linked. Hydrogen fuels stars. Stars forge elements. Those elements seed future clouds. In regions untouched by stars, hydrogen remains pure. In regions where stars lived and died, space becomes richer, more complex. Both states are necessary. The universe needs places that change and places that remember. As you rest now, your breathing mirrors this rhythm. Inhale, exhale, fuel, release. Nothing rushed, nothing forced. Some stars blaze loudly and announce their passing. Others dim quietly and leave behind something deeper. Both paths are valid. Both contribute. to the larger story. Imagine drifting near a primordial hydrogen cloud. It is vast, cold, almost invisible. No sharp edges, no bright centers, just a gentle presence, spread thin across space. Now imagine, far away, a massive star reaching its final moment. No explosion, just a soft fading as gravity closes in and silence takes shape. Between these two scenes lies everything else. Galaxies, planets, life, thought. The universe does not favor noise over quiet. It allows both, and so can you. There is no need to replay the day. No need to resolve every thought. Some thoughts can simply fade, like stars that choose silence. Others can remain untouched, like hydrogen clouds, waiting patiently for a future that may never come. Rest does not require conclusion. It only requires permission. As the universe drifts onward, still growing, still merging, still remembering, you can drift inward, towards stillness, towards softness, towards sleep. The cosmos will continue, whether observed or not. Hydrogen will linger. Stars will end quietly. Galaxies will reshape over eons. You do not need to follow all of it. Tonight, it is enough to know that even the universe sometimes chooses silence, and in that silence, everything is held. After stars die in silence, their material does not vanish. It cools, it spreads, it waits. Over vast stretches of time, gravity begins its slow, patient work again, guiding gas and dust toward the sweeping lanes of the Milky Way's spiral arms. These arms are not solid structures. They are patterns, gentle waves moving through the galactic disk, compressing material as they pass. Where the wave flows, space becomes denser, and where density increases, something remarkable happens. Hydrogen gathers. At first, it is only a thin mist, barely distinguishable from the surrounding darkness. But gradually, clouds begin to form. Immenser clouds, giant molecular clouds, some spanning hundreds of light years, containing enough material to form tens of thousands of stars. These are the stellar nurseries of the galaxy. They are cold, far colder than most people imagine. Temperatures fall to just a few degrees above absolute zero, allowing atoms to bond, forming molecules, mostly molecular hydrogen, along with traces of carbon monoxide, water, and organic compounds. In this cold, dark environment, gravity gains the upper hand. Tiny irregularities within the cloud become seeds, a slightly denser region here, a gentle compression there. Over time, these seeds grow. The cloud fragments into countless clumps, each one slowly collapsing inward. At the center of each collapsing clump, a protostar begins to form. At first, it does not shine. It is wrapped in thick layers of dust and gas, hidden from visible light. Only infrared radiation escapes, a soft warmth in the cold dark. Inside, pressure rises. The core grows hotter, denser, more focused. This process takes millions of years. Unhurried, methodical. There is no sudden spark, only a gradual deepening. And then, when conditions are finally right, hydrogen fusion ignites. A star is born. This moment does not announce itself loudly across the galaxy. It simply begins. Light pushes outward. Gravity balances inward. A new sun takes its place. Within the spiral arm, around it, other stars are forming too. Clusters emerge. Groups of siblings born from the same cloud, sharing similar ages and compositions. Some are massive, burning bright and blue, living fast and briefly. Others are small, cool red dwarfs, destined to glow quietly for trillions of years. Together, they illuminate the spiral arms. This is why spiral arms shine, not because they contain more stars overall, but because they contain younger, brighter ones. As stars age, They drift away from the arms, settling into the broader disk of the galaxy. The arms themselves continue moving, compressing new clouds, igniting new generations. It is a cycle without urgency. Creation does not rush. The spiral arms are like slow-moving rivers, flowing not with water, but with gravity. They shape where stars are born, without ever holding them forever. Inside these stellar nurseries, the environment is both gentle and intense. Radiation from newly formed massive stars begins to carve cavities into the surrounding clouds. Ultraviolet light ionizes hydrogen, causing it to glow softly in shades of red and pink. These glowing regions, nebulae, are among the most beautiful structures in the galaxy. Yet they are also destructive. Stellar winds and radiation can halt further star formation nearby, dispersing gas back into space. Creation and destruction happen together. One star's birth can end another's potential. Still, on large scales, the process balances itself. As one cloud is dispersed, another is compressed elsewhere. The galaxy breathes. Inhale, exhale. Over billions of years, this slow breathing has shaped the Milky Way's appearance. The graceful spiral pattern we imagine is written in newborn starlight. Without stellar nurseries, the galaxy would fade. Without spiral arms, star formation would be slower, more scattered, less organized. Yet even here, nothing is permanent. Spiral arms can change. They can weaken. They can shift. Some galaxies lose their arms entirely, becoming smooth, quiet disks or featureless ellipses. The Milky Way, for now, still carries its winding structure, still gathers gas, still forms stars, but it will not always do so. As time passes, hydrogen becomes scarcer. Each generation of stars locks more material into long-lived forms: white dwarfs, neutron stars, black holes. The reservoirs slowly drain. Star formation will one day decline, becoming rare, then nearly impossible. The stellar nurseries will quiet. The spiral arms will dim. But that time lies far in the future, so distant that even imagining it feels abstract. For now, creation continues, and there is something deeply calming about knowing that star birth is not explosive, not chaotic, but gradual and patient. It unfolds in darkness, in cold, in silence, just as rest does. You do not fall asleep instantly. Your thoughts slow, your body softens, tension dissipates, layer by layer. Sleep, like star formation, cannot be forced. It happens when conditions are right. As you listen now, imagine drifting along a spiral arm, not rushing, not resisting, just moving with the slow current. Around you, clouds of hydrogen glow faintly, lit from within by stars that are barely awake. Dust particles float like soft snow, absorbing sound, absorbing urgency. Somewhere within these clouds, new suns are forming. Not for us, not for anyone, simply because gravity and time allow it. This is not a performance. It is a process. The universe does not seek attention. It simply continues. From primordial hydrogen to silent stellar deaths to luminous nurseries hidden in spiral arms, the Milky Way tells a story without words. A story of balance, of endings feeding beginnings, of light emerging gently from darkness. You are part of this rhythm. Your atoms were once inside stars. Your breath echoes cosmic cycles. And just as stars are allowed to form slowly, you are allowed to rest slowly. Nothing is required of you now. The galaxy will keep turning. The arms will keep shaping light. Stars will keep being born. Long after this moment passes, for now, you can simply drift. Let your thoughts thin, like gas clouds spreading in space. Let awareness soften, like starlight filtered through dust. Creation does not need your attention. Sleep does not need effort. Somewhere in the Milky Way, a star is being born quietly. Somewhere else, another is fading without sound. And here, between those vast processes, you can rest. The spiral arms will hold the story. You do not have to. Surrounding the luminous disk of the Milky Way is a vast, spherical region known as the galactic halo. It is not something we easily see. There are no bright spiral arms here, no glowing nebulae rich with color, no dense clouds forming new stars. Instead, there is space and silence and age. The halo extends far beyond the visible boundaries of the galaxy, stretching hundreds of thousands of light years into darkness. It envelops everything, like a faint, invisible atmosphere around a glowing ember. Within this halo reside some of the oldest structures the Milky Way possesses. Among them, the globular clusters. These are not loose gatherings of stars. They are dense, tightly bound spheres, each containing tens of thousands, sometimes millions, of stars packed together in a remarkably compact volume. From a distance, they resemble faint, fuzzy orbs. Up close, they are dazzling swarms of ancient suns, locked together by gravity in an enduring embrace. Most globular clusters formed more than 12 billion years ago, not long after the universe itself began. They are older than the spiral arms, older than the galactic disk, older than the Sun, by a wide margin. When these clusters formed, the Milky Way was not yet the graceful spiral we imagine today. It was a chaotic assembly of fragments, smaller proto-galaxies merging and colliding, pulling each other apart and stitching themselves together. Globular clusters are survivors from that era. They formed early, quickly, from dense clouds of gas that collapsed before heavy elements became common. As a result, their stars are chemically primitive. They contain very little iron or heavier elements, revealing their birth in a universe that had not yet been enriched by generations of stellar explosions. In this way, globular clusters act as cosmic fossils. They preserve the conditions of the early universe, encoded in the light of their stars, unlike the dynamic spiral arms, where stars are born, drift, and disperse. Globular clusters are astonishingly stable. They orbit the galaxy as cohesive units, often on elongated, tilted paths that pass above and below the galactic disk. Some plunge through the disk, unperturbed, like ancient travelers crossing a busy plain. Others remain far out in the halo, circling slowly in darkness. Their orbits tell stories. By mapping these paths, astronomers can trace the history of past mergers, ancient dwarf galaxies that were torn apart, their stars scattered into streams, their globular clusters left behind as enduring witnesses. In fact, many of the Milky Way's globular clusters did not form here at all. They were born in other galaxies. Long ago, smaller galaxies ventured too close, and gravity did the rest. The Milky Way absorbed them, stretching them, dismantling them. Their stars blended into the halo. Their clusters survived intact. Thus, the halo is not just empty space. It is an archive, a memory vault, a record of encounters spanning billions of years. And woven throughout this vast region is something even more elusive: dark matter. The halo contains most of the Milky Way's mass, yet very little of its light. Dark matter forms an enormous, invisible scaffold that extends well beyond the stars. Without it, the galaxy would not hold together. The spiral arms would unravel, the disk would disperse, the clusters would drift away. Instead, everything remains bound, moving in quiet, graceful orbits around a center they cannot see. This unseen presence shapes the halo's structure, guides the motion of globular clusters, and preserves the galaxy's form. Over immense spans of time, The halo is where motion slows. Stars here move at great distances from one another, rarely interacting, rarely changing. It is a realm of longevity. In the dense heart of a globular cluster, however, something different occurs. Stars are packed so closely that gravitational encounters are common. Over billions of years, these interactions reshape the cluster from within. Heavier stars sink toward the center. Lighter stars migrate outward. Some stars are ejected entirely, joining the halo as solitary wanderers. Yet despite this constant internal motion, the cluster as a whole endures. Its overall shape remains. Its core continues to shine. This balance between internal change and external stability is deeply calming. It reminds us that movement does not always mean disruption. Sometimes it is simply adjustment. Unlike the stellar nurseries we left behind, globular clusters do not create new stars. Their gas was used up long ago or stripped away. What remains is a population of aging stars, slowly evolving. Red giants swell gently. White dwarfs cool quietly. Occasionally, a neutron star or a black hole lurks unseen among them. Yet even here, there is subtle beauty. Some clusters host blue stragglers, stars that appear younger and hotter than they should be. They form when stars merge or transfer mass, renewing themselves briefly in an otherwise ancient environment. Even in the oldest places, there are hints of renewal. The halo, too, is not static. Streams of stars arc through it. Remnants of galaxies long consumed, still stretched across space. Like fading brushstrokes, these stellar streams move slowly, almost imperceptibly, but they carry precise information about the Milky Way's gravitational field. They trace the contours of dark matter's invisible shape. From afar, the halo would be nearly invisible. If you stood far outside the galaxy, you might see only the glowing disk, unaware of the vast sphere surrounding it. Yet the halo is essential. It stabilizes, it preserves, it remembers. There is something profoundly soothing about this outer realm. It does not rush, it does not sparkle, it does not demand attention. It simply exists, holding the past, while allowing the present to unfold. In human life, we often focus on the bright disk, the busy regions of activity, creation, and change. But rest lives in the halo, in the spaces where nothing urgent happens, in the distance from noise, in the gentle awareness that time is vast and patient. As you listen now, imagine drifting beyond the spiral arms, leaving behind the glow of newborn stars. The light dims. The galaxy becomes quieter. Around you, globular clusters float like lanterns, each one containing ancient light that has traveled for billions of years to reach this moment. They do not flicker. They glow steadily, unconcerned with the present. Their stars have seen the galaxy assemble, collide, and grow. They will likely remain long after the spiral arms fade. There is comfort in this endurance, in knowing that not everything must change quickly. Some things are meant to last. Your breath slows. Your thoughts soften. Like stars in the halo, they drift farther apart, less dense, less insistent. Nothing is pulling them inward now. Gravity loosens. The universe expands gently around you. You are not at the center, and that is restful. The Milky Way's halo does not seek attention, yet without it, nothing else would endure. In the same way, your quiet moments support everything else you do. They are not empty. They are foundational. As globular clusters continue their slow orbits, as dark matter silently shapes their paths, the galaxy holds itself together without effort. And you, listening now, are allowed to do the same. No striving. No urgency, just gentle presence. Within a vast, ancient structure, that knows how to endure. The halo surrounds the galaxy. Silence surrounds thought, and rest surrounds you, softly, patiently, like an ancient cluster of stars, shining without hurry. In the dark, at first glance, a dead star sounds like an ending. A white dwarf, the small, dense core left behind after a sun-like star exhausts its fuel, appears quiet, dim, and final. Its bright days are over. Its nuclear fires have faded. It no longer shines with youthful intensity. And yet, this is not a place of true silence. A white dwarf is not nothing. It is a memory made solid. A stellar heart, compressed and glowing softly with residual heat, slowly cooling across billions of years. Around some of these stellar remnants, planets still exist. They survived the violent final breaths of their parent stars, when outer layers were shed into space, when gravity shifted, when everything seemed unstable. Some planets were destroyed, some were flung outward into darkness, but others remained, finding new orbits, new balances. These worlds circle a star that no longer burns, yet still radiates warmth, still exerts gravity, still provides a center. In the quiet glow of a white dwarf, a planet could experience something rare: stability. White dwarfs change very slowly. Their light fades over immense timescales, far longer than the active lifetimes of most stars. This creates a gentle, predictable environment. If a planet orbits at just the right distance, temperatures could remain steady for billions of years. Not hot, not cold, just calm. In theory, liquid water could exist on such a world, and where liquid water exists, chemistry becomes patient, complex, creative. Life, if it arises, would do so under a faint amber sky, lit by a small, steady star that never flares, never explodes, never rushes. It is a profoundly peaceful image. A planet warmed by the afterglow of a dead sun, experiencing long, quiet days, long, quiet nights. Time would move differently there. No sudden changes, no violent bursts of radiation, just continuity. And even beyond planets, the Milky Way itself is filled with the raw ingredients of life. Between the stars, within vast molecular clouds, float complex organic molecules, alcohols, amino acids, carbon chains, ring-shaped compounds. They form naturally, slowly, as atoms meet on icy dust grains, as radiation gently rearranges bonds, as cold chemistry unfolds over millions of years. These molecules do not rush. They assemble in darkness, at temperatures close to absolute zero, guided by simple physical laws. They drift, they wait. Some will eventually become part of new stars, new planets, new oceans. Others may remain in space forever, quietly existing without purpose, without urgency. And that is enough. What is remarkable is not just that these molecules exist, but that they are widespread. They are not rare accidents. They are common features of galaxies. The Milky Way is not sterile. It is chemically rich, filled with complexity, even in its coldest regions. This suggests something gentle and reassuring. The universe does not fight against life. It prepares for it, patiently, again and again. Even after stars die, their material becomes something else. Planetary nebulae, the colorful shells cast off by dying stars, seed space with carbon, oxygen, nitrogen. These elements are carried outward, mixing with clouds, becoming part of future systems. Death is not removal, it is redistribution. In the halo, we saw endurance. In white dwarfs and molecular clouds, we see continuity. Nothing truly stops. It only changes pace. Around white dwarfs, astronomers have detected disks of debris, rings of dust formed from shattered asteroids and comets. These disks contain water-rich minerals, organic compounds, the same materials that once helped shape Earth. This means that even after a star's active life ends, its system can remain chemically active. Impacts still happen, material still moves, complexity still grows. Some scientists even speculate that life around white dwarfs might have more time than life around stars like our Sun. Because while the Sun will eventually swell and destabilize Earth, a white dwarf offers a long, calm twilight, lasting trillions of years. In the far future of the universe, when bright stars are rare, white dwarfs may become the last steady beacons, around which life could quietly persist. It is a humbling thought that life's refuge may not be found in brilliance, but in gentleness, not in explosive beginnings, but in soft endings. As you listen now, notice how this idea feels. There is comfort in it, in knowing that even when energy fades, meaning does not disappear. Between the stars, organic molecules continue their slow dance. They do not know they are important. They do not aim to become life. They simply follow physics, bonding and separating, over and over. And yet, from this simplicity, possibility emerges. In your own life, moments of quiet often feel unproductive, unremarkable, but they are where subtle changes occur, where thoughts rearrange, where emotions settle, where something new can eventually form. The Milky Way does not rush its chemistry. It allows time to do the work. White dwarfs cool slowly. Molecules drift slowly. Galaxies evolve slowly. And in that slowness, there is safety. There is room. The halo we explored before was a place of memory. This final region is a place of potential. Not loud, not obvious, but persistent. Life around dead stars reminds us that endings are rarely absolute. They are transitions into quieter states. States that still support existence, still allow complexity, still offer warmth in subtle ways. As your breathing becomes slower, as your thoughts grow softer, you are mirroring the universe's preferred pace. No sudden changes, no sharp edges, just gradual cooling, gentle drifting, steady presence. Imagine floating now, far from the galactic center, far from bright nurseries. Around you, the faint glow of white dwarfs dots the darkness like distant embers. Between them, clouds of molecules shimmer invisibly, holding the ingredients of countless futures. Nothing demands attention. Everything simply exists. The Milky Way is not only a story of stars being born and exploding, it is also a story of what remains, of quiet orbits, of fading light, of chemistry unfolding in darkness. And that story is deeply restful because it tells us that there is no deadline for meaning, no requirement to burn brightly. Sometimes, existing gently is enough. As this journey through the Milky Way comes to rest, there is no dramatic ending, no final explosion, just a gradual softening. The galaxy continues. Life's ingredients continue. Time continues. And you are allowed to rest within that continuity, like a planet orbiting a quiet star, like a molecule drifting between suns, like a thought fading into sleep. Nothing is lost. Everything becomes quieter. And in that quiet, rest arrives naturally, without effort, without fear. Good night.